All right, last video of fluid balance. So we're going to talk about actually fluid moving. Okay, so we've got a few objectives here. And so we're going to talk about basically how fluid moves and the different kinds of conditions we can be in. Okay, so when it comes to electrolytes, they contribute to osmotic pressure. Now, electrolytes can break up into ions, into smaller ions, okay? Non-electrolytes don't break apart in water. So, for example, think of salt. So salt is NaCl, right? So NaCl gets into water, and it turns into Na and Cl. Okay, that should be written closer together. Glucose, on the other hand, sugar, doesn't break up into different ions, okay? So glucose is a non-electrolyte. However, both of these contribute to osmotic pressure, and sodium and chloride are the main ones, okay, or the ones that play the biggest role. And this is because they're concentrated outside of the cell, highly concentrated. So potassium doesn't play as big of a role. All right. Now, capillaries also play a role in fluid balance because capillaries let fluid move, they let ions move. If you have a leaky capillary, you're going to have edema because fluid is crossing the wall. And so sometimes, most of the time, this isn't a big deal because we can filter it out using our lymphatic system. But sometimes that fluid builds up and we get edema. And so a couple examples of increasing permeability, maybe when we don't normally want to, is if we get injured, such as a burn. So people that burn units, they lose a lot of fluid and they can become dehydrated. All right, and then histamine, like antihistamines, like you've heard of that. Well, histamine causes your capillaries to be leaky. And so that's what's happening when people have allergies. Histamine's activated. So what do you take? You take an antihistamine so you stop being leaky, so you stop having a runny nose, that sort of thing. Okay, and that decreases capillary permeability. Now, when it comes to fluid balance, we have to consider both volume and osmolarity. And so we've got a couple of different ways that this can happen. So if we increase volume but decrease osmolarity, that's just you're drinking a lot of water. Okay? We're not changing the amount of salt in our body. We're just changing the amount of water that's in the extracellular fluid. Now, if we drink a lot of salt water that has the same concentration as basically the plasma, we're going to increase our volume, but we're not going to change the osmolarity. Okay, so like 0.9% of salt, that's usually what's in saline. Like when you get IVs, that's pretty similar to your osmolarity in your bloodstream. Or you can ingest super salt water, so what we call hypertonic saline. So you'll increase your volume, but you'll also increase your osmolarity. Now, if you don't change your volume, but you decrease your osmolarity, well, what you're doing is you sweat a lot and you just drink water. You don't replace it with other electrolytes. Okay? If you don't change volume and you don't change osmolarity, that means nothing's happening, so life's just normal. Okay? You can increase your osmolarity without changing in volume. That would be you just ingest some salt. So this is what my brother used to do as a kid. He used to eat a rock salt. He's a little weird, but there you go. Okay? If we decrease volume and decrease osmolarity, well, that means we're dehydrated. In other words, we've had fluid loss, but we haven't drank enough or we haven't ingested enough water to make up for what we've lost via sweating. If we lose a lot of volume but don't change osmolarity, that's when you like do something like hemorrhage, so you have blood loss, because blood has the same concentration, right? Like we're not losing salt and water in unequal amounts. It's the same proportion. But we are losing volume. And then the last one is dehydration. So you can decrease your volume, but have an increase in osmolarity. So if you sweat a whole bunch, especially if you're effective at it, and what I mean by that, if you're heat acclimated, you actually have we have a small amount of ions in it, or diarrhea. Okay. So with dehydration, there's two primary effects. We have decreased blood volume and pressure and increased blood osmolarity. And so why are these issues? Well, they can lead to this: dizziness, fainting, lethargy. I never know how to say that word. It could also affect action potentials. So let's take this from a low blood volume standpoint. If I have low blood volume, that means the fluid in my extracellular compartment is low, so like low plasma volume. This is sensed in your atria by those baroreceptors we talked about. And so there's also baroreceptors in your aortic arch and your carotid sinus. So what ultimately happens is we've got low volume, which means low pressure. We increase our sympathetic activity. We decrease our parasympathetic activity to try and compensate for that. So we're going to have a high cardiac output, but we might not increase it enough to return blood pressure to normal. Okay? Now, if we have high osmolarity, how might we respond? Well, in this case, we're going to change aldosterone and vasopressin. Okay, so I'll increase vasopressin because I want to hold on to as much water as I can to decrease that osmolarity, but I'm going to have low aldosterone so I can get rid of salt to lower my osmolarity back to normal. Now, it's also possible, I just think it's something I should bring up, that you can actually drink too much water. It is very, very difficult to do, but it can happen. Okay, when this happens, when you become hyperhydrated, you also experience something called hyponatremia. And I can't find my there it is, hyponatremia right here. In other words, you have super low salt concentration. Okay, and so what happens is you have lots of fluid in your extracellular compartment. That causes your salt concentration to be very low. You're not changing the amount of salt, you're just changing the concentration. And so if you experience this, you just do the opposite of what happens during dehydration. So we're going to increase sodium or decrease our fluid. Okay, so we're going to increase our aldosterone and decrease our vasopressin. And as a result, we'll be able to get rid of excess fluid while holding on to salt. And so that is how we're going to end the fluid balance part of this program.